Okay, G, let's begin. This is May June 2025. The variant is 65. Let's start solving quickly. The random variable x has the Poisson distribution. The sum of three independent values of x is denoted by this. Okay, the sum of three independent values of x is denoted by s. तो s का lambda हो जाएगा Poisson बन जाएगा 3 into 1.5. So I get Poisson 4.5. So probability of 0, 1, 2, and 3. Okay, 0, 1, 2, and 3. So e power minus 4.5, then 1 plus 4.5 plus 4.5 squared over 2 factorial plus 4.5 cube over 3 factorial. Okay, you add all of them up, you get an answer that says 0.342. Okay, then show that the exact value of this is 125 over 44. So e power minus lambda. Okay, so let's first write down probability of 0, 1, and 2. Probability of 0 and 1. So e power minus 4.5 is 1 plus 4.5 plus 4.5 square over 2 factorial. E power minus 4.5, 1 plus 4.5. So what does the numerator give me? I think I can cancel out the denominators. Cancel out the e's, sorry, in the denominator. So this gives me, I will have to calculate this on my calculator. So 125 over 8 over 5.5. So 125 over 44 is the final answer. Okay, let's erase this and do this again because I might have done this for another class. Random sample of this gives the following results. Find a 95% confidence interval for the mean of x. Now, this is a question that tests your knowledge of S1 as well. So, for the confidence interval, you're going to need all of these values, z value into sigma over root n, and mu x bar plus z value into sigma over root n. Okay, since I need all of these values, what I'm going to say is that I remember from S1 that the mean of x minus 2 is the same as mean of x and minus 2 separately. Okay, so what is the mean of x minus 2? It's 60 over 200. X bar minus 2. So x bar is then 2.3. Okay, variance of x minus 2 is the same as variance of x. Okay, so that is sum of x minus 2 whole square, 20 over 200 minus 60 over 200 squared. Okay, I'm applying the variance formula. I just want the variance of x. I am going to unbias it in a bit. 20 divided by, so I'm getting 0.01 variance of x. Okay, I will have to unbias that number to end up with the value for sigma. Sigma square is 200 over 199 multiplied by 0.01. So 0, I'm going to use the exact number 2 over 199. Okay, so let's construct the confidence interval now. 2.3 minus the value for the 95% confidence interval is 97.5. So that's 1.96. 1.96 uh, into 2 over 199 divided by 200 and 2.3 plus 1.96 into 2 over 199. Okay, so 2.3 minus 1.96 into root of 2 divided by 199 over 200. 2.29 and 2.31. I hope those are the correct answers. Yes, those are the correct answers. Let's move on. State what happens, which part of the solution makes use of the central limit theorem using the z values from the normal distribution. From the normal distribution, that is where the central limit theorem applies, because the central limit theorem is about using the normal distribution table. Okay. Okay, let's do this question again as well. I might have solved this for another class. Okay. Okay, let's see. Formula's calculator can generate random numbers between this and that, inclusive, correct to three significant figures. She plans to use her calculator to choose a random sample of from 851 club members. She numbers the numbers from 1 to 851, then she uses her calculator to generate some random numbers. She multiplies each random number by 851 and rounds up to the nearest whole number to give the number of a member in the sample. This is called a member number. Marula's first random number is this. Find the member number that is produced by this. So 0.401 multiplied by 851. What does that give her? 0.401 multiplied by 851. Okay, that gives her 344.655. She rounds up. So 345 is the member number she's looking for. Okay, 345. Point. Oh, my bad. Okay, let's look at question 3. Marula's calculator can generate random numbers between this and that, correct to the nearest three significant figures. She plans to use her calculator to choose a random sample of 851 members in her health club. She numbers the numbers from 1 to 851. Then she uses her calculator to generate some random numbers. She multiplies each random number by 851 and rounds up. Okay, to give a number from the sample. This is called a member number. So find the member number that is produced by this. So multiplied by 851.401 multiplied by 851. That's 341.251. Round up. So member number should be 342. Okay, that was easy. Find all possible random numbers correct to three significant three decimal places. That would produce the following member numbers. So I want this to be 680. I know that this has to be 851. What is my random number that I'm multiplying? So first I'm going to divide 680 by 851. Okay, that gives me 0.799. Okay, so what I should really do is I should check 0.799, is that the only number that gives me 680? So what I'm going to do on the side is 0.799 multiplied by 851. Let's see what that gives us, because I have to round off to three decimal places, right? 79905 आ रहा था नहीं? Okay, so 799506. Sorry, so 79.799. This gives me 679.949. Okay, so 0.799 sounds correct. It's going to round off and give me this. So my final answer should be 799. But can it be 798 as well? That's what I should check. Okay, 798. What does 0.798 gives me? 0.798 gives me 851, because I'm very close to 680, right? So there might be a number. This is giving me 679.098. So I think there's another number here that rounds off to 680. Okay, so you have to give me both numbers, otherwise it would be incorrect. Okay, yeah, this is a bit of trial and error. There's no other explanation for it. Okay, again, what's 850 divided by 851? Okay, so that gives me 0.9988. So what two numbers should I check? I should check 0.999. Okay, let's check 0.999 multiplied by 851. 0.999 multiplied by 851. It gives me 850.1. So it doesn't work. Why? Because I want the number 850. I can't round down. I have to round up. So I'm going to check the number 0.998 now. Okay, 0.998. That gives me 849.2. Okay, so I think 298. So 0.998 is the number that rounds off. I should also check 0.997. I'm doing that on my calculator. It's giving me 848.447. That means it rounds off to 849. That shouldn't be the correct answer. Explain briefly why your answers to part B show that Marula's method does not produce a random sample. Some member numbers, such as 680, have two three decimal numbers that give a member number of 680, which means that some numbers will have more probability than others. Okay. Okay. The number of cars and trucks arriving per minute at a fuel station are modeled by independent variables, this and that, respectively, per minute. Okay. Then I'm asking you find the probability that at least four cars and at least two trucks arrive during a randomly chosen 5 minute period. So lambda for 5 minutes. Cars is zero point 0.8 into 5 is 4, and trucks is zero point 0.5 into 5 is 2.5. Okay. So then at least four cars and at least two trucks. So 1 minus probability of 0, 1, 2, and 3. 1 minus 0, 1. Okay. 1 minus e power minus 4, 1 plus 4 plus 4 square over 2 factorial plus 4 cube over 3 factorial. 1 minus 1 minus e power minus 2.5. So 1 plus 2.5. Okay. I wrote the wrong expression. So I'm going to put this all on a calculator right now. And my final answer comes out as 0.404. Okay. I hope that's the correct working and answer. Yeah. Okay. You can put everything on a calculator in one go and get your final answer. Okay. Part B uses suitable approximation to find that the total of fewer than 145 cars and trucks arrive at a fuel station during a randomly chosen 2 hour period. So in 1 minute, the total lambda is 1.3 for 1 minute. For 2 hours, 1.3 into 120. So 1.3 into 120, 156. So then total follows a normal distribution with 156 comma 156. What do I want? I want the probability to be less fewer than 145. Okay, first I'm going to do a continuity correction. Okay, 144.5 minus 156 divided by root of 156. 921, 5 minus 0.921, 1 minus 5.1, 8215. 8215. 0.1785. 0.179 should be my final answer. Okay. Question number 5. Candidates for a certain diploma take two tests. The mark for the first test and the second test are modeled by the independent variables with distributions this and that. The final mark F for each candidate is found by doubling the mark in the first test and adding the result to the mark in the second test. Okay, so the final mark. Okay, find the probability that F bar. Okay, this is a sampling question. So F bar should follow a normal distribution with mu and sigma square divided by n. So let's first find the final mark. Okay, then the final marks is 2 times 38.1 plus 64, comma. Now for the variance, since I've doubled the marks, it's going to be 2 square times 3.8 square plus 6.1 square. Okay, I get a total. What is my total? It's 140.2. And for this, I have the total 94.97. Okay, then F bar should have a normal distribution with 140.2 and 94.97 divided by 25. What is the probability that I want? I want F bar to be greater than 143. Okay, F bar to be greater than 143. So Z 143 minus 140.2 divided by 94.97 divided by 25. Okay, 1.437. 1 minus 5, 1.437. What's 1.437? 1.437. 9246. 0.0754. Yeah, that is the correct answer. Let's move on to question 6 quickly. Let's claim that 28% of the voters in a certain town support the forward now political party. A researcher suspects that the true figure is less than 0.28. He interviews a random sample of 30 and finds that 4 voters. So test statistic is 4 in this case. He plans to carry out a hypothesis test at this 10% significance level. So I think that's easy. X is less than or equals to 4. I write down 0, 1, 2, and 3, and 4 as well. 4. So that's 30C0, 30C1, 30C2, 30C3, 30C4, 0.72. Power 30, 0.72 power 29. I have to write all of this because the examiner wants working. I cannot do it without working. I'm just being quick about this. So I'm just writing it like that. I know that my calculator can accumulate. So I'm going to do that right after I'm done writing. Okay, so my calculator is giving me an answer from the cumulative distribution that says 30. No, I want to accumulate up till 4, 30, and 0.28. Okay, so my answer is 0.0495. 0.0495 is less than the significance level. Okay, reject H naught. There is evidence to suggest that less than 28% voters support the forward now party. Okay, easy question. Let's do the next one. State with the reason whether it is possible for a type 1 error was made. Yes, because H naught was rejected. It. Okay, that's all you need to write. Later, the researcher carries out a similar test at the 10% significance level using a random sample of 30 voters. Find the probability of a type 1 error. The type 1 error is always with trial and error on the rejection region. I know that the rejection region is not at 4. So I am going to try out probability of x less than or equals to 5. That's 0.04954 plus 30C5 0.72 power 25.28 power 5. I'm getting 0.1161. Okay. So I'm going to say that x is less than or equals to 4 is the rejection region then, because this is greater than 10%. And probability of type 1 is equals to 0.0495 only. Okay. That's the same probability that you found out earlier, but you have to do a bit of trial and error before you can conclude that. You can't just directly write that. Okay, quickly moving on to question number 7. I must have solved this for someone before, so it's marked here. I'm going to do it again. Okay, there are two questions in fact. Question number 7. It says a firm makes a certain type of cars. The battery life is denoted by X hours, and the population mean of X is supposed to be 12. The quality control department wishes to test whether the mean population is supposed to be 12. The quality control wishes to test whether the population mean of X is actually less than 12. They tested a random sample of 50 of these toys and found that the sample mean of X bar was 11.4. State suitable null and alternate hypotheses for this test. So H naught is mu is 12. H1 is mu is less than 12. You may assume that the standard deviation of the battery life is 2.3. Show that the value x bar leads to rejection of the null hypothesis at the rejection region. Okay, so 95%. What does 95% give me? 95% gives me 1.645. 1.645 on the lower tail, so minus 1.645. Z value of test statistic is 11.4 minus 12 divided by root of 2.3 divided by root of 50. Okay, what does that give me? It gives me minus 1.845. Minus 1.845 falls in the rejection region, so reject H naught. Okay. It is given that the value of x bar leads to rejection of the null hypothesis at the alpha percent significance level. State the possible values of alpha. Now, what I am then saying is that minus 1.845 falls inside the rejection region. That is what I know. Okay. It's certainly getting rejected at the 5% significance level. So there's probably a lower significance level where it also got rejected. So what I'm going to do is I'm going to try and to find this probability. I'm going to try and to find this probability, the minimum amount of alpha where H naught is going to be rejected. So this is going to be phi of minus 1.845, 1 minus phi of 1.845. What's 1.845 read from the table? If I read this from the table quickly, 1.845, 1.8, 9675, 9675. 1 minus 0.9675, 0.0325. Okay, so that's the minimum amount of significance level. So significance level has to be greater than 3.25 alpha percent has to be greater than 3.25% for each not to be rejected. Okay, let's quickly look at this last question. Again, I've done this for someone before, but I'm going to do it again and see. Okay, short question. So between x0 and the graph consists of a straight line with gradient k. So gradient is k, where k and a are positive constant, else where f of x equals to 0. It is given that the median is root 2. So this area is then zero point 0.5. Okay, this area is 0.5. Okay, find the value of k. So first, can I say that half base into height is going to be 1? I don't know what the height is. I'm going to say that I get 2 over a as the height. 2 over a. I just have to find the value of k in this regard, right? So can I construct an equation first? Can I say that mx plus c, y equals to mx plus c, y and c is 0 basically, so kx plus 0. So the equation of this line is kx, y equals to kx. What I'm going to simply do is 0 to root 2 kx should equal 0.5. Why? Because it's the median. So kx square over 2 with the limits 0 to root 2 equals to 0.5. So that gives me k root 2 squared over 2 minus 0 equals to 0.5. So k is basically just 2 over 2 equals to 0.5. So k is just 0.5 then. I didn't really need to do this part, but I did it anyway. Okay, it's probably going to help me in the next question. I don't think it's going to help me in the next one either. Or I can actually find out the value of a. Okay, now I can say that 0 to a, the equation of the line is 0.5x. That should equal 1. So 0.5x square over 2 from 0 to a to 1. So zero point 0.5 a square over 2 minus 0 equals to a square is then 2 over 0.5. A square is then 4. A should be plus and minus 2, but I'm just going to take it as 2. So 2 is the value of a. Okay, that makes the expectation easy for me. It's x f of x from 0 to 2. So x into kx, 0.5x. So 0.5x square has to be integrated, 0.5 cube over 3, 0 to 2, 0.5 2 cubed over 3 minus 0. Okay, let me check if I am doing this correctly. I think my answer should be fine. 0.5 into 8 divided by, I'm getting 4 over 3. Okay, that's the end of this exam, I think. Thank you for watching.